Good morning, everyone. Very good to see you all here. I hope you're ready for this talk, which has a title that's way too long. But apparently, it's not a problem for all kinds of graphical designers involved in the conference, and even on the systems running here at the RAI. Well, the title just fits on the screen. Although I've added some extra words later on, so maybe if we try this again, things will break. So microservices is maybe the word that is from the. Oh, it's actually quite funny that microservice isn't in the title. I now realize this. But this talk is about microservices, and then again, it is not about microservices. So that's something that will be of interest to you, I guess, because it needs some fixing. The word itself needs some fixing, and also any kind of cultural aspect around it needs some fixing too. So I will dive into all of these aspects. So for now, like maybe this was a big surprise, microservices, oh no, let's not talk about those stupid things. But then postpone your judgment. We will be discussing this, like do we really need to call it microservices? Is it really that bad? Everything will be covered this morning. So maybe first, what is a microservice? Well, what is not a microservice? It's basically, we should consider its counterpart, that is the monolith. It's sometimes a feared thing, sometimes it's a much appreciated thing, since it will basically bring in usually a lot of money into the organization, where developers maybe want to split it up, but well, yeah, who is going to touch this mighty thing that works so well and makes us so very happy? So what is a monolith? It's just a really big application. Usually it's big. It can also be a small one. But the idea is that every aspect of the business, the domain model, any kind of infrastructure, everything is defined in one code base for one project, one system. And then with microservices, basically what you have is a lot of different services all working together to do the same thing that basically the monolith would be able to accomplish. So the microservices have been split according to some sort of a data model separation, or maybe some behavior or some domain knowledge, things like that. These determine the boundaries or the limits of each of the services. But then micro isn't really that important. It isn't about size. It's more about having these separate services. And well, it doesn't really matter. If there are 2 or 3 or 100, maybe if you are working with 100 services, things are going to become much more difficult. But for this talk, it's really important just to consider just the idea that maybe your system, your application would be better off as a set of smaller services. And this is where I think culture comes into play. There are so many people talking about microservices and they don't have any experience with it, just like me. In fact, I've not been working on a production system running microservices. I have seen several of those teams working with microservices. I think that it's just a good idea to not talk about all of this in a negative sense. If you don't have the experience, just like open your mind to the possibility that there is something about it that may be interesting to consider for your next project, but even maybe for your current project. So I think they deserve a chance. And basically, the thing is that there are some problems about them, but I think these are perceived problems. There should be a closer look, like just trying to investigate what's really going on with these problems that we are so scary about of encountering when we start doing the microservices. So one thing is this quote by Simon Brown. There's an article, distributed big balls of mud. Oh, that already starts out well, right? If you can't build a monolith, what makes you think microservices are the answer? So this guy is pretty angry at us. We get the sense that, yeah, so first fix our stuff, you know. We have to be better at building monoliths, and then maybe we can consider splitting those up into separate services. Because, yeah, what will happen, of course, is if we are very bad at this monolith business, then we're going to end up with shitty microservices. I'm not sure if I can say shitty, but I just said it. There it is. It has been recorded as well. So let's hope there's no repercussions about this. Okay, so the thing is, we have some great answers from this for this, and these things have surfaced just in the last couple of years they are called bounded contexts. And this is one technology, or maybe not a technology, but a technique from domain-driven design, where this allows us to basically find out where the boundaries are for our services. So diving into this topic might be just a way to solve the issue of how to split actually our services, our monolith into services. And it basically works like this. You have this one business domain. Usually you're developing a monolith which represents all of this business domain in terms of domain model and behavior. And now with bounded context, you basically separate the domain into subdomains, and you designate part of the subdomain, or part of the domain, which is the subdomain, to one service. Basically one service. As you can see, there is one in this like maybe pinkish bounded context. There are several other maybe like triangles. These are just services that may be separately deployed. So within a context, you might end up with multiple services, if you like. But the first step is to find out where are the subdomains and how can we create bounded context for those. Because of the time, I don't have much time to dive into this topic, but it's just like a pointer. If you're scared about splitting up your monolith into services, then first look into the topic of bounded context, since this will give you a lot of pointers for doing so. So next up is this nice image of a microservice system. You can see that many things are going wrong there. That's basically, so I find this a very, very fascinating animation. You could look maybe for minutes to the screen and still find out some new things that are breaking. Basically, a service architecture or microservice architecture feels like there are way too many moving parts. That's, of course, like the big guys. They create these systems, like Amazon and Google. They have thousands, maybe millions of services running, and of course, something is going to be wrong about them. Something is going to break. But this is not for you. Like I will get back to this later. We are not Amazon, we are not Netflix, so we don't have to worry about those things. And instead of choosing all of these little services, we might as well just take this slider from monolith to a lot of services and end up somewhere in between. Like 2 or 3 services, that's already great. It will really help you separate things out a much. Okay, then this may be another familiar picture. Like, who knows the game? Probably a lot, yeah. It's yeah, we call it Cluedo, but I'm not sure if it's Clue or Clue, right? Cluedo. Okay, so a microservice architecture or system is assumed to end up like one big murder mystery. Something breaks, and then we don't know who did it or what was the cause. Probably all kinds of services are going to scream when something goes wrong because, well, everything is relying on everything else. So this is going to be really hard to figure out. This is why one of the microservices requirements, like you have to be ready for adopting the architecture, is just to have proper monitoring in place. You need to be sure that whatever is running in your system runs well, and you have to define some cues for this, like what are the performance numbers, what are the number of problems. You know, this is just an example. It's just not like I like it because of the colors on the black. It just really stands out well. But it's more about figuring out what's going on in the system and having a good clue about this. Then you define some of the possible numbers, like you expect a number to be around 80, and then if it drops to 10 or maybe rises to 300, then you have to configure some alerts. You have to be notified about things that may be going wrong in the system. And of course, you just need a lot of logging. And with logging comes a central system which aggregates all the logs from all the services and all the nodes in the clusters. And then, well, of course, you have to sort of correlate these things. So there's correlation identifiers. That's just a technical idea of linking all of the log messages like in one sort of a stream where you can figure out what has been happening from user request to final outcome. So this is basically, it may be a pain to set up at first, but not more than a couple of days before you can just rely on it for a longer time and tweak it as soon as some of your requirements change. This is really something you have to have in place before you start thinking about chopping up your monolith system. Then again, I do believe that a monolithic system also benefits from such a logging, monitoring, alerting system, but well, we don't use it that much, I think, in practice. So another picture of a microservice system. I think so. A big part of what was the problem with the murder mystery is well, can be solved by reworking this. This is basically just a big network of dependencies, services calling each other, needing each other for their data and their behavior. But there is a really simple answer to this, and every service-oriented architecture or microservice book will tell you this. You have to maximize service autonomy. You don't have to, or you should make sure that services are not relying on each other at runtime, not calling each other, not waiting for each other, not breaking when the other one breaks. And this is why, well, we have a hard time grasping these ideas. We, as PHP developers, are very much used to request-response flows and just making some calls and just waiting for everything to finish, right? This is what it looks like. As a user, we call a service A. It may need some service B, and, well, A waits while B finishes, and the user still waits for A and B to finish. What if B breaks? You have to be sure that there is some fallback mechanism or some like user interface friendly thing going on. Yeah, we've maybe heard of circuit breakers. It's not really cool because, well, if some service is flaky and you do some sort of a fallback mechanism to some other service maybe, that's a service again which can break. Maybe you have some cache data that you can serve instead, but yeah, that's going to be stale data. This is not really the best solution. So instead of doing all kinds of trickery at this network level, you have to look for asynchronous integration. Again, there's not much time to go into the technical details of all of this, but it's just like pointers to where you can look at if you're interested in this topic. So basically what you do is you cut the dependency from user to service and to other services. There is only a dependency from the user to the outer layer of the system, which is going to accept the calls. And from that point on, everything else will be handled in the background asynchronously. And the user will get some feedback eventually, but not while they're waiting. So that's just the basic idea of cutting the system into autonomous services. And that's where something like this, a messaging solution comes into play. You need something that is able to keep requests or store events as well, and then process them later. So you will need some messaging solution for that. And this brings you from like well, making direct calls, fetching data from services, to instead basically inverting the dependency direction. Make sure that the service that's going to handle something is actually not doing this directly, but putting a message on a queue, and then some other services are going to fetch the message and do their work later at some point in time that is convenient to them. So there's no dependency in time. Nobody's waiting for the other services to finish their work, but of course the work has to be done at some point. So it's going to be back at where you expected it to be. Okay. Then another perceived problem will be technology circus. I'm sure if you've been considering microservices, it's because you want to experiment with different languages in your company, different technologies, and you just want to have this service in PHP, this service in C#. Well, and it doesn't really matter. Maybe you want a MySQL database and a MongoDB database. Well, MongoDB database or Mongo database. You may be worried about things getting out of hand in your company, like people trying all kinds of hobby projects, using all kinds of cool languages, maybe Erlang, in their microservices. And things will become very much unmaintainable. Of course, like maybe just one person knows this language or knows this database technology, and then things are going to get out of hand. So one thing to realize is that microservices isn't just a free technology circus for everyone. You're still a company, you still have to produce working software, and you have to maintain this software. So it's very important that you decide on some standards. Maybe there is a standards team in your company. Maybe you decide on this together if you're in a smaller team. But definitely decide which languages are you going to use. Maybe pick two, one like PHP that is good for web requests, and one like Go or Node that is good for background processes. But make sure you know what's going on in the application. You don't have to continuously do pull requests and code reviews for each other, but at least be sure that there are no crazy things happening, unless, of course, explicitly agreed upon. More about this later. This will definitely lead to an increase in development speed, like the server system combined with all kinds of process changes that I will discuss in a minute, will help you develop in a much faster fashion, like produce more software and really start working on new features without influencing the functionality of the bigger system. So the other thing that I mentioned, you are not Google, you're not Amazon, not Netflix. That's one of the counter arguments usually for not even considering a microservice architecture. So for sure, we shouldn't just cargo cult anything that is going on there. We shouldn't just accept any advice from them, because yeah, of course, most of us are in a different situation than they are. What's really important is that the biggest difference is, like, we may not be them, but that's maybe especially because we don't have that amount of requests to process. We don't have usually the issues of scale in our companies. So in that case, I would just say, yeah, start small. Pick this small number of services and don't aim for a lot of requests at the same time or a lot of concurrency of concurrent processing. Don't start with a large cluster and all kinds of replicas. Just start small and like move your way to, well, maybe better places if you really need to. But I guess things can become much better if you start really small. In fact, I've been working with Docker for a couple of months now, trying to find some resources on this, and some people who are working with it too. Combining this knowledge and experience, I can say that the tools are there. We can definitely, like Docker is just a product, of course, but the idea of containerizing your software really helps in also taking your next step in service architecture land. So. That's just something I wanted to mention here. Maybe it will take another couple of years before everyone is using Docker, but that's not the issue here. I'm not preaching this particular product. I'm preaching service architecture and containerization, which is a good thing for services. While you're getting acquainted with all these new tools, and there are many of them, so it may take some time, you can definitely learn on the job. If you're starting small with the small number of services, you will find out what are the issues of having these services communicate with each other through messaging, likely. What are the needs in terms of logging and monitoring. So you will learn and improve your product based on what is really required in your company. So my hypothesis, and that's where I started this at the beginning of this year, trying to, or in fact writing a book about this subject. I'm actually thinking that even with a small team, this can be beneficial. And also, if you want to prepare for a bigger team, like the software is going to grow, the application is going to get bigger, then it may make a lot of sense to divide your monolithic system into services, and maybe even start out with 2 services to begin with, in order to experience what comes into play when you start doing these service-oriented architectures. But that's an hypothesis. We still have to prove it in some way, like over the coming years probably. So this may be just like the pioneering subject that you will hear more about in a couple of years when people are actually applying it successfully. I mean, many people are applying it successfully, but not so much in our PHP world, right? So maybe that's going to change in a while. What I think is great about microservice architecture is that it shakes out a lot of the issues in well, your organization as well as your application. And problems that you didn't realize you had are suddenly very clear and transparent on screen. So that's a very interesting thing. Maybe if you're not looking for problems, then don't look into microservices. But if you want to improve things in your organization as well as in your product, then it's a good thing to consider it. What's fascinating about the architecture itself, but also about the related processes in your company, these like microservices require some changes, but they also enable some changes. And one of these is continuous delivery. With microservices, with services that we have explicitly containerized, maybe using Docker, maybe using some other container tool, we can now have like this one thing that really travels across the build pipeline. If you know about continuous delivery, it's all about that. So yeah, I'm basically already skipping a slide. So this continuous delivery is where you take your code, and every change to it will result in a separate release. It's going to be wrapped like in a container, for example, a container image. And this one is going to travel across a pipeline, taking more and more steps to sort of validate this build. And then if all of the tests pass, and maybe it has been analyzed in some way, like does it improve the performance or not, or is it secure enough, then finally it will be marked as releasable, and you can push the button to deploy. You can also take it one step further and do continuous deployment if you like, but the idea is that every little change to your project results in a new releasable thing. And in fact, with container images, this is really something that becomes possible. So it basically enables a continuous delivery. But with microservices, you really it requires continuous delivery, because if you would manually deploy all of the services, then well, you will run crazy, of course. This will become very, very painful. So you have to automate all of this. And this goes, again, in two directions. So this will make your application much better. It will give you higher quality, better testability, and it will automate a lot of painful steps that you used to do manually before. But it also requires it. So this is just a circle in which the service architecture makes you move. If you have this in place, the continuous delivery like pipeline or a life cycle, then change becomes really very fast. And every change that you make will be a safe change, since all of the tests will run and all of the integration will be verified. So in the end, everything will be much better. You will be able to work faster and in a safer way. And for every change, there's also a previous version of the build. So there's a previous release to which you can roll back if you like. So, but rolling back is a different story and might require another talk, but you get the idea. So with automation, it's more like, maybe you've heard this before, if it hurts, do it often. And in particular, if it hurts to do it manually, then do it often, but make sure that it happens in an automated fashion as well. So just doing it manually a lot of times doesn't really help. Create a script for it, or maybe even an application that solves your issues. What this really means is that you're basically moving towards a DevOps culture. I think this has been popular a couple of years ago, but I think it's even more important today. Like a DevOps culture is where everybody feels the same responsibility in terms of, like, we make a change to the code, but we also have to release it, we also have to deploy it, and we have to make sure that it runs correctly in a production environment. So that's where shared responsibility really is the key word. But also agility, and that's an interesting thing, because if you know as a developer how to deploy and make your code run, then you can actually become much more faster and responding to change more quickly, because you now know how to make it, how to produce the new feature and make it run in production. So it's a really good thing to make this happen, because, well, most companies I know, there is some sort of a delay, where you have to decide, like, are we really going to release this, and all of the features are going to pile up, and then nobody dares to even release. It's becoming dangerous to do so. So if you continuously release and maybe continuously deploy as well, then well, things are going to be much safer and faster. So yeah, tools are getting better every day. Like basically, if you're talking about container tools, there's a new tool every day. So that's maybe a bit of a problem. You have to figure out if this is the right thing for me. But even there will be new releases every day or every week, maybe. So there is maybe a bit of an issue here where you have to keep track of whatever is going on in this landscape, in this in particular containerization landscape. That's not really a nice thing, at least for you. It should be, well, maybe a little bit more quiet in a while, where it's just like, oh, use this and you will be good. So that may take a little while to settle in, but I guess in 1 or 2 years everything should be, or the dust should be settled. What's interesting is that, just like I mentioned, what is required is bounded context, but it also enables us to work with these bounded contexts. Well, we used to be looking for ways to split up our domain model. Like we usually have this one big domain model, and now we're looking for the smaller ones. And this seldomly is something that is successful. As Eric Evans, I paraphrased him here from a video on like his talk on microservices. The very natural and as well as technical limit imposed on the domain model really helps for modularization. If you're looking at a monolithic application, you have all the code in one code base, you have all the database tables accessible in one code base. So it doesn't really matter if you actually look for the clean model boundaries. You can just grab anything you like. With these services, there is the natural, even like the network-based boundary between the services. So you really have to be thinking about how do I get this information, and how do I get how can I call this behavior that's inside the other service. So for bounded context, you need them, but they are also actually enabled by a service architecture. So that's an interesting thing. One of the other circles of like enabling and requiring. And the same goes for team autonomy. Like if you're working on a monolithic application, you all may need everyone else in the organization to get something done. If you're looking for a service architecture, there will be more moving parts, so you have to drastically cut the number of communication lines between teams or developers, because otherwise you would end up being in meetings all day, and that's something that we all don't want. Again, this is requirement and enablement. We can now look for autonomous teams. Autonomous services can be developed by autonomous teams, but it's actually required. If you don't do this, then you will end up talking all day to each other. And one of the things that you will be doing is reducing bottlenecks. If you feel that one team working on one service continuously has a request for meetings and has to consider all kinds of integration issues with other teams, then this has to be redistributed. Something is wrong about the workload, something is wrong about the amount of pressure that is put on one team. So reducing bottlenecks, there's a whole business there, theory of constraints, where you always look for like where is the bottleneck now, we can remove it and make the whole organization work faster. So that's a very interesting thing, something that I think many IT organizations are not that good at currently. So we just keep going on and keep going from meeting to meeting to finally tick off all the boxes and produce our features. But we might be better off looking at ways to maybe shuffle the work items, for example, to accomplish like faster throughput. Besides all of this, like we have all requirements, which are basically enablements. We can now do all kinds of cool things. There are some extras to microservice architecture, because basically we have these services, and well, instead of like in the case of the monolith, we were so much worried about keeping this thing running, and well, how do we ever add new features to it? How do we fix the issues that it has? And now we can basically say, like, if we have multiple services, well, they are more or less throwaway services, if they are small enough, of course. And we don't do this lightly, but at least we can replace parts of the bigger system by new services. We just redevelop them, maybe even if we like using a different language or different other kinds of technologies. So we just, well, the services themselves become less important. And not only in terms of code, but also in terms of the runtime. If we're running services on some sort of a cluster environment, the idea is that we can just take down the service and create a new one, or maybe spin it up again. So this feeling of disposability is something that's really, really good about software. And it will help us write also the code that is required to accomplish our goals, instead of the code that is able to fulfill every future goal, like we may be inclined to do in terms of like generic coding, where we just want to make the ultimate solution to things. Now we just look for ways to make it pragmatic, make it work, make sure that we create the services that fulfill some sort of a need, well, from the customer or the user. So we can just basically rewrite things and well, try out something else. We can also experiment, like maybe if we sort of want to migrate to a different language, or we want to figure out if some database technology is something for us, then it's very easy to take one service and build it in some other language using the other technology. Maybe even we first split another service into two parts, which can then be replaced even in more fine-grained ways. And this allows for a polyglot approach, where, well, different languages, different libraries, different storage mechanisms, different communication ways, or serialization techniques. You can try out different things, and this will really help you to innovate faster. I think this is another thing that may be something for a lot of IT organizations, where, and probably you know this, but then the boss has to know it too. Innovation is really key to software development. If you can't try out new technologies, because you're probably working on some monolithic system, then the company is slowing itself down. You have to prepare for the future, try out new things, try out the better things, and continuously learn about stuff. And as I'm sure you all know, if you're working on this monolithic system, it's a legacy code already. There is a fixed number of dependencies that you can use, maybe a fixed kinds of other services that you can rely on. But there is no way to innovate. In the container ecosystem, this is really cool, where you can just pull in any kind of official container, or maybe someone who has containerized some tool that you are interested in, and you just try it out. And it comes with a level of isolation that's important. You don't have to embrace it entirely. It's not like you have to get some approval from someone. You can just try it out in one smaller area of the architecture. So I know that this is still quite of a scary topic, maybe for PHP developers, including myself. There is a bit of a well, we can be scared about this. It's not very much sure that this will all work, and I think I've seen several cases now where the approach was microservices, but it ended up being basically like microliths, basically monoliths, but packed as services. Although I think that if you're now looking into this, you should definitely consider it. In particular, if you're considering like re-architecting a system or redesigning it, or maybe you're looking at one new big system that you have to design from the bottom up, then definitely consider like going for at least 2 or 3 services. Like first divide the domain into subdomains, and just figure it out. Like, could this work for us? And well, like I said, my hypothesis is that it can work. As I mentioned, I'm doing a lot of research about it. I'm writing a book about it. Microservices for everyone. If you're interested, at some point it will be finished, probably in 6 or 8 weeks from now. But it is already available if you like, so just Google this. And what I do believe is that if you try this at home, and if you try this and be successful about it, and you will be back next year at this conference, then I'm sure you will be very popular. You can talk about this with everyone, and maybe you will get some rounds of applause for it. So with that comes the end of my talk. If you have some questions, then there is actually a lot of time. We have 10 minutes, so I guess you should just ask me anything. I'm not sure if there are microphones or things like that for the, yeah. Oh, let me just walk to there. Yeah.
Hello. I was wondering, with 1 or 2 microservices, it's not a problem. But if you have many microservices, how do you document messages which are going into a message queue, and how do you prevent duplicate messages or events?
Mm-hmm. Okay, so the question is how to document the events which go from service to service. That's right, so every service should have some sort of a documentation endpoint where you could look up what is going on. Ideally, there is some situation that is called living documentation, where the messages that are actually sent inside the application as data structures are also like one-to-one available as documentation. I don't know about frameworks for this, so it might require a little bit of manual work. But yeah, just like if you're working on some code, you define an interface, for example, like at the code level. You say, oh, I want this interface to work, so you provide an implementation for it. That's a way to divide work amongst team members. It's the same for microservices, where the events really become the interfaces, so to say. So this will be the collaboration keystone or cornerstone. So it's definitely important to document it and talk about it. It may be even the case that in terms of meetings between teams, you just agree on the events that are going to be sent, to be created. Yeah. Okay. Does that answer your question? Cool. Yep.
So you mentioned that microservices can even work for small teams, but do you have any advice on at which point do you split up into multiple teams where every team has its own microservices, or is there well, I'm sure you can't say 7, but is there like a general point where you can say, well, maybe it's time to split up teams and give every team its own set of microservices to look after?
Yeah. Okay. So the question is when to split. What will be the size, or maybe like the slider. Where do I decide to create a new team? There is no general rule. I think the best rule is to start with the larger services, of course, and for that, the bounded context from domain-driven design are a really good starting point. There is some interesting material. I should find out a way to share that, maybe on Twitter, by Nick Toon in particular, who has done some work on discovering these service boundaries. And he says that it's more about team autonomy than bounded context, in fact. Like bounded context is really focused on where the subdomains are, but team autonomy is more about how can we be as quick as possible to deliver value to our customers. So when it comes to team autonomy, maybe the key point will be noticing some issues in the organization or in the team where you're basically preventing each other from working autonomously. Like you're waiting for some other team to deliver some stuff, or maybe some other developer, in fact. So that will be the sign to maybe redivide the work and the boundaries as well. Okay. Does that help?
Yep.
Great. Yep.
So how about cascading failures? Because if every service can ask for the other dependencies to be up, then it will fail if that's not the case. So do you think every service should behave nicely even though its dependencies are down?
Okay, so the question of cascading failure, I already had it on the screen where you have the circuit breakers. That's an implementation pattern that allows you to respond to failures in other services. That's something you can do if there's no way to circumvent actually calling the other service and waiting for the response. Like I mentioned, asynchronous integration is basically the answer. Make sure that that nobody is actually waiting for the other service to finish their response. The request response flow. So maybe that sounds easy, but it may be difficult in practice, because at some point you just have to handle some request. That's why I mentioned that there is the service, like the system consisting of the services. The outer layer is able or is available for calls from the outside, but they just take the calls, don't do anything yet, but just put it on some queuing mechanism where services are going to respond. Then if the service that's responding to a message is making a call that fails because the other service is down, it can just retry. And if you have designed your system well enough, then it's going to be a signal to you as well, as the maintainer, that something is wrong. So you have some time to bring it up again. Sometimes the cluster scheduling tool is able to do so, like rebooting the service if something goes wrong. And then it's just a matter of retrying. And so cascading failure turns into sort of a delayed success. that's maybe the conceptual transition you made there. Okay. Thanks. Yep. Mm-hmm.
I understand the way you say, like, if you have everything asynchronous, then you can build at some point the answer. But how you will do that? I mean, I can have a lot of services.
Mm-hmm.
So if I process a request and I know I have to call, say, 5 services to finish the request,
Mm-hmm.
then I do that. I call the 5, but then I have to build the answer in some point. At some point, I have to build all the answer and give it back.
Yep.
So how do you do, or what's your advice for building that endpoint that is have to wait for all the answer from all the services and then rebuild the whole thing and answer back?
Okay, so the question is about retrieving data from services, and probably it's going to be data built up from several other services data, right? So like basically taking components and like you would normally do several queries and then generate a view based on a template, something like that. The one clue about like really autonomous services is that they use or they leverage data locality. And data locality is about where is my data, and you should make sure that the data is already where you want it to be. So this is a little bit of a paradox where like if your services communicate using events, then you just listen into all of the relevant events from other services and build up your own local representation of the data that you need. It's, if you know CQRS, that's basically the same principle, but then it's across services. This means that the data is eventually consistent, but that's what you really need, because like just calling other services is impossible. It will make you less autonomous or not autonomous at all. So when it comes to querying data, it already has to be there. That's at least one of the tricks that you can use. Yeah, but then in general, there is just the 2 branches of activity, like getting data and creating changes. Like this is maybe the traditional distinction between commands and queries, or queries and commands. And for commands, you can always delay those. For queries, you just have to make sure that you can already answer them. Yeah. Maybe again, this sounds easier than it is. But it's just to give you some general idea for the solution. Oh. Okay. Yep.
Hi. Can you give an example of a proper bounded context?
Mm-hmm.
So if, for example, I describe a process, let's say that there is a process and then you want to invite someone to participate.
Mm-hmm.
So there is the service that handles the process, and there is an invitation service somewhere.
Mm-hmm.
So with a message, you can send the invitation, but by the time the other person will accept the invitation, maybe the process is closed. Who owns the rules there?
Okay, so the question is about bounded context, but I also think that it's about how do you communicate between processes if they may not be up and running.
Yes, because for example, the process of accepting an invitation, which happens on the invitation service, is happening asynchronous. So the person will accept it on a Saturday night, for example. What happens if by that time the process is closed because the other user that owns the process, for example, is terminated?
Yeah. Okay. So it's about.
I don't know, a discussion.
Yeah. Yeah. So the user is already away from the screen. So your system has to be designed for this entirely. So you just have to be able to respond to the user not being there, or maybe something else that's going wrong. Like time is really going to be ending up in the design of the system. Like passing of time and asynchronous in general. So you have to have some fallback mechanisms there as well.
What's the business rule? That can I accept? Can I invite that person in that process or discussion? It's very important.
Okay. Yeah. Well, in terms of processes and guarding like the flow of it, there is a technology or technique called process management. That might be something to look into. This sagas, yes, for sure. Because, well, that's the difference between something called choreography and orchestration. And with a single process manager, you can manage multiple contexts, events from multiple contexts, if you like. So that's one way to sort of.
Is Saga a separate service then?
Yeah.
Can it be
Yes.
considered separate,
Yeah, so in theory, services don't know about each other, but of course, we are all talking about one big application that makes sure that one big use case is actually working. One process can be finished eventually in several steps. So there has to be something that's keeping track of all of these different steps and the status of the process as a whole. Yeah, so that may be just another pointer for you to look into. Okay, we have. Oh, it's already 10:30, by the way. I think we have to just make room for the next one. Thanks for attending. If you have some feedback, go over here. The slides can be found here as well. And the video and audio will be available after some time. So, thank you.